And that brings me to the next speakers. And that's, I hope I pronounced it right. I think they're Italian names. Correct me if I'm wrong. It's Natale Vinto and Fabio Di Vita. Was that okay? They're putting their thumbs up, so I think I passed my my name test. Natale Vinto and Fabio Di Vita. Fabio, 20 years of experience, works with solutions around integration projects for enterprise-grade customers related to cloud-based architecture, agile integration, event-driven architecture. For me, just words, but the crowd is probably going wild. Yeah, you look pretty trained in it. Natale has a 10 years experience in IT, ICT, software engineer, and he's a developer advocate for Openshift, helping the community to have success with their Kubernetes and cloud native strategy. A mouthful, but what they're going to talk about here today for you is the next step in the cloud journey, edge computing with Openshift. And in general, it's just saying, the business is going super fast. Everybody needs to adapt. Like we talked yesterday, the world is moving fast. Technology, software, it's all coming. So you have to keep up and make sure that you choose the right things and the right solutions. And they say edge computing plus all these new technologies that I've mentioned before will help businesses and the people watching here today achieve those challenging business goals that we have today. So without further ado, gentlemen, I would say I'm looking forward. The digital floor is yours.
Hello, everyone. Thanks, Martin, for the big presentation. Happy to be here for the fourth year in a row, probably. Started in 2016, so I'm happy to be here with my fond friend and colleague, Natale Vinto. We are going to speak about edge computing as the next step into the cloud journey. And we will see what does it mean for that. Please, Natale, would like to introduce you. Over to you.
Hey, hello everyone. I'm very happy to stay here at Openslava again. Happy to see you again, Marnik. It was a long time. We see very, very cool to stay here at Openslava also this year. My name is Natale Vinto. I'm a software engineer, and I'm working with that as developer advocate. Feel free to ping me by email or on Twitter at Natale Vinto. And I'm going to introduce my colleague, Fabio.
Thanks. Yes, I'm Fabio. I work as a solution architect in Red Hat, looking after GSI's technical relationship. Just to say, always looking for the next big way to write. And edge computing looks like is one of them. If you want to ping me, please feel free to do it at my email, fdvita@redhat.com.
Gentlemen, can I jump in real quick? Yeah.
Yeah, please.
I see you looking. It's not God. It's Marnik. We're asking just to have the live stream correct for the coming hour that you're presenting. Could you put it in full screen if possible?
Yes.
All right, that would be great. Thank you very much. Sorry for disturbing.
Nope. Here it is. So edge computing, the open source way. The advent of cloud computing has a big relationship with the amount of money the money coming from cloud computing has a big relationship with the growth of data. And this is from this picture that I suggest you take a look at. And that means that cloud computing and this growth of data is providing a huge opportunity to the company to create a new value for the end customer and create the insight that they can create from this value can improve the services that the enterprise going or adopting the cloud pattern can create for their customer. That doesn't mean that create value from data or going to the cloud computing environment create necessarily a direct relationship with creating value from the data. This is that's a great challenges. Just create applications that create value from this data. Because the more are the data you have to manage. Probably the biggest is the need to create or to deploy application where are needed. That does mean that you probably in the next future, or let's say now, is probably not enough just the cloud pattern deployment as we already know, but probably you need to put the workloads next to the customers just to provide the real-time insight. Things about like autonomous driving. Just probably you need to produce some feedback where the cars are instead of moving back and forward data from the neighbors, let's call it the edge, and the data centers, whatever kind of data center you are, public cloud, private cloud, whatever it is. So edge computing is going to provide this kind of benefits. So bringing any workloads and anywhere. What does it mean for Red Hat, which is the point of view Red Hat regarding edge computing? It just brings computing, storage, and network services closer to users and data sources. And then that has great consequences in brings also the workloads where closer to user and data sources. Looking at the way we try to draw the edge tiers or how we see edge tiers, we probably can identify 3 or 4 more main layers. One is the provider enterprise core, where we include the core data centers, the one that we are used to know. Then there are the regional data centers, that there is the works as an intermediation between the last mile and the enterprise core data center. And then there is the end user, the edge next to the end user, the one we are going to focus more in the next minutes. And there's the ones that provides the main benefits, but at the same time the main challenge. Edge computing is already happening, is now, is not yet. We are looking at the future, but it is something that is already in the market, is already implemented in industry, like telco, looking at the private networks and the virtual radio access network that enable telco provider to scale better to the requirements coming from digital mobile, for example, access, or manufacturing, looking at the requirements coming from implementing predictive maintenance for the plants that can improve the way that the manufacturer company can manage things that are not next to the data centers, but are very far. And the same we can tell for the energy and oil companies, which are going to implement more and more process control, digital process control, and next to the place where this kind of control is needed. And the manufacturing, energy, and telco are not the only ones market where this transformation is happening, or retail. We think about shoppers or remote office. These are all use cases that where edge computing is bringing now great benefits. Which are these benefits? You think about latency or reducing latency, so that if you were able to bring workload services next to the customer and the user customer, it's far easier to provide them. Obviously, the kind of feedback or be more proactive, reducing the bandwidth, because obviously you don't need to bring back and forward data from edge and data center. And I think one of the best things, the best benefit probably is a resilience, because if you are able to deploy any kind of edge platform where it is needed, you can probably avoid one single point of failure. So if you have one plant with one edge deployment and that deployment doesn't work, this doesn't mean that you will have an impact on overall services on the other plants where you have your other edge deployment. Creating or having this kind of benefits obviously doesn't come for free. I mean, if you think about managing a very highly distributed architecture, probably you have to deal with a bigger complexity. So you have to think about managing small cluster around geographically distributed. And you have probably managed this kind of a complexity with this same team. So you don't want to just increase number of people that have to manage all this kind of complexity. And you have to manage probably a multi-layer stack, I mean, different technology that must be integrated and must be integrated in a consistent way wherever you are, local data center, central data center, edge. Companies, customers have obviously two choices to leverage this kind of benefit and implement their edge vision, their edge strategy. One is just locating in vertical solution, provided that very good for sure vertical integrated providers. But beyond the benefit, I think end user and customer, should be have to figure out how they want to move forward the first implementation. So having instead an open iterable architecture coming from the adoption of open source solution means that you have probably a better way to improve your vision to the edge future. So continuous open source innovation coming from the way open source work and innovate. For us, edge computing is just part of a broader solution coming from the cloud adoption. So that's why we say this next step in the cloud journey, where we identify three main streams. One is just adopting an edge-enabled distributed platform. The other one is having an event-driven architecture, deploy them in your edge environment. That means you can identify your services and having an effective way to use your computing resource, mainly if you have to deploy a small cluster into the edge. And last but not least, having AI and ML application, intelligent, as we call intelligent application, deployed in the edge and deployed in a consistent way in all the different kind of edge tiers that probably company have to deal with. If we start from the Red Hat architecture approach to the edge deployment, Red Hat Openshift for sure has the capability to provide a consistent way to manage clusters, Openshift clusters starting from the central data center to going to the neighbors, the edge. So you don't need to reskill your a customer doesn't need to reskill his IT department or operational OT department. And also from managing the workloads or building application, building on Openshift into the edge or building the application in a data center doesn't mean a lot in terms of skills. And you can manage the workflow of deploying applications of what we call CI/CD in a manner that is not that different from the way people really skilled on this kind of platform is used to do now. looking at a different way you can leverage OpenShift right now in order to have an architecture, an edge-enabled architecture based on OpenShift, we can see that you can deploy a single edge cluster made by 3 node, a remote worker nodes, or having even a single node edge server, till to the small footprint device edge. This should be able to fit the different kind of use cases where you have, for example, low bandwidth or disconnected sites. That's the one of the use cases where probably deploying a single node edge server could fit very well, or having space constrained environment. So you can deploy a central data center cluster or in a regional data center cluster and a remote worker, just to deploy very straightforward application. Then you can have probably the need to have a small footprint with a high availability. And that means you can have deployment of just a single node edge cluster. All these different way to deploy OpenShift from architectural point of view can address different kind of use cases and different kind of vertical. Thinking about single node edge server, we can just address, for example, asset monitoring or healthcare data processing. And that means telco, obviously, with the telco 5G far edge radio access network, or manufacturing. Remote worker nodes, think about connected sensor or fraud management system. And so also fintech is impacted by this kind of edge deployment. Edge cluster with 3 nodes. So Red Hat OpenShift and masters and worker reside on the same node. You have so the capability to deploy edge AI and data pipelining. So you have in your intelligent application next where your proactive action must be provided. And this is a way you can, that's a picture of how you can manage from a central data center with single tool of management, all these different kind of deployment. Or looking at a different point of view from industrial point of view, you can have a manufacturing use case where you have to need with IoT, machine learning, you have to manage to deal with industrial control with different factory plant managed centrally, or a telco use case where you have ultra low latency and precision time synchronization. That is not enough, obviously, because having OpenShift cluster empty doesn't mean anything. You need to manage workloads. So you need to bring application where to the edge. What does it mean in terms of needs that must be addressed? Having CI/CD pipeline consistently managed from data center to the edge, or having a declarative current configuration management in order to replicate wherever you want, or in case of need, or manage business continuity, disaster recovery from the data center to the edge, leveraging GitOps patterns. You have data processing from sensor to analytics, managing in a way that's not that different from the way you usually manage a usual application, traditional application. And so using the CI/CD pipeline that we already know. Creating value from that application and delivering them faster is a value for sure. So whatever kind of application you have to deal with, but is not enough just deliver faster. You have to deliver safer. Safer means in terms of be sure to deliver the kind of things you are supposed to do. So implement the CI/CD pipeline based on whatever tool you want that is integrated with OpenShift. Things about Tecton, the OpenShift pipeline, Kubernetes native way to manage pipeline or Jenkins as well from the central data center, where you probably have the development phase to the execution at the edge. The same should be true also for intelligent applications. So creating training the model in the data center and deploy the final intelligent application, promoting to production to the geo-distributed factories or plant, whatever they want, in a consistent way always. We don't want to reinvent the wheel. So that's the reason why Openshift provide GitOps capabilities through having a consistent vision of your workloads through whatever kind of workloads you have to deal with, from the data center to the edge, throughout the different steps: dev, test, staging, and prod. Even triggered business logic. What does it mean actually, and how is really implemented on Openshift? Natale, over to you, and please, can you give us some more insight on what does it mean on Openshift, even triggered business logic? Please.
My pleasure, Fabio. So if you can drive the slide now, we can continue this way. There are a bunch of animations, so if you get them, can click. Yeah, so why serverless in this edge computing world? So if you recall, we had the a nice OpenSlava session back in 2018, where we were talking about serverless. And the concept is always the same, but here we are trying to adopt this to this new concept of edge. So why we need serverless over here? If you know, historically we were developing with monoliths, application servers, and XMD architecture and design. And now we have this new approach, which is the serverless approach, right? Which is simplification towards Kubernetes. And moreover, it enables a dynamic scaling. That's an important thing. And what we get from this, that technology is an utility. And this serverless approach is really helpful because it helps us abstracting this complexity. Some numbers from the market. So 40% of enterprises adopted serverless technologies. We've expected growth coming in next year, or next 18 months. And 60% of serverless practitioners reported reduction of operational costs. So those are very nice metrics to hear about. Let's see, what is that serverless? So with serverless, usually we have an event. This event can be about HTTP requests, Kafka messages. Typically, this event triggers your application, and your application produces some results. So this is the serverless pattern explained. In the context of OpenShift, Kubernetes, cloud native world, what we have usually is a container of a bunch of containers that responds to some HTTP requests from our browser, from our API call, consult a database, and we have this auto-scaling way of delivering the content. The benefit of this model is that you can scale down to 0 when you don't use this service. So you can save resources, and you can scale it up when there are lots of demands. If you think about edge computing, right, we can have really a huge number of devices, of inputs connected. So having this model working here, it's really a big plus for our strategy. And serverless pattern is not only for HTTP requests, right? It's just reacting to any kind of event. If you think about a queue or a Kafka message, so some data streaming, this is another great fit for serverless. So we have some streaming, some message streaming from some external system, and we create automatically a container that talks to a storage, and we can auto scale it up. When we don't use it, this container goes down. And we can see in this slide, we have some operational benefit from adopting serverless. because usually we tend to over provisioning our hardware resources, so we don't know really what we need unless we measure and unless we do all the metrics. With serverless, we have from day zero those metrics fitting our workloads, because we can just have the hardware resources responding to the real demand, to the real load. And this is the overview on how is structured OpenShift serverless, so how it's made. So you have, of course, the RHEL CoreOS operating system, which is a basic operating system based on containers. Then you have OpenShift, so the Kubernetes enterprise distribution. We put on top on OpenShift this serverless layer, which is component by three modules. One is the serving, the one implementing the scale to zero we were talking about before. The other one is eventing, the one that is reacting to event, Kafka messages, or any kind of other streaming. And then we have the function. So the capability to run just a piece of code and auto-build it, auto-compile it, auto-deploy it. This is the offer around OpenShift serverless, based on Knative project, which is the Kubernetes native serverless implementation. Around that, you can have also an ecosystem of tooling. So we're talking about Knative. Then we can use Istio for the service mesh. We can use some external tool like CADA integration for Azure Function. We can have our favorite runtime. So we can implement our function in our Python, Node.js, Java, Go, PHP favorite runtime. And the builder, the component in OpenShift server will build the containers automatically for us. If you see, the developer are in charge of the function layer, microservices layer, and the operation SRE people will be in charge of setting this up in top on OpenShift. The key feature here, as we say, is that we have automatic scaling. This is an event-driven architecture. As Fabio was mentioning, with edge computing, we expect to have a massive, huge, lots of data to manage, to handle, to react to. So this is the best fit computing model to deal with those kind of architecture, and moreover, based on containers technology. Let's talk about use case, typical use cases for serverless. So one of the typical use cases is just web application or API. So I want to expose my service. My service to talk with some database, something like this. I can build my service in my favorite programming language like Java, Quarkus, Node.js, Go, and Knative and OpenShift will build for me and run this for me. And when I don't use this service will be scaled up, down. If I want to do my blue-green, my canary strategy, I can serve multiple versions of my service, my function, and this can only the one that I need will be really active. So this is very powerful. Another good use case example is this one. So Fabio will talk in details about AI, ML use case for edge computing, but also for serverless. This is a good use case because we mentioned that when we have to react to lots of data, we have to manage lots of events. Think about an automation around machine learning. In this example here, managing some X-ray data for health system. You have lots of data to manage. You can react and scale according and proportionally to your business need with this paradigm. And the data transformation. So data transformation is really one of the best fit for serverless. If you think here in the edge world, so this can be a device of a sensor sending some data, some event. And you can use also on top of Knative and OpenShift, some tool like Apache Camel, so Fuse from Red Hat integration to transform your data. So you serve the data with serverless and you transform the data with Camel in a agnostic way. So this is another great use case for that. And just to recap everything, in this new world where everything is ubiquitous. The computing model has been diffused and dispersed everywhere. So this serverless use case, this serverless paradigm is really helpful, and moreover in the edge computing world. And Fabio is gonna talk to you a little bit more in detail about all those data with machine learning workloads with edge computing that you can serve and manage with also with serverless framework.
Yeah, thanks, Natale, for presenting a very effective way the serverless part. I mean, I think is one of the main enabler if you want to use effectively an edge computing deployment and fill that edge deployment with effective and useful and valuable application that should consume or use the resources, the scarce resources that usually you have to the edge in a wise way. AI/ML, so create the deployment into the edge or capability to deploy or to consume data coming from the edge and provide proactive action to the inside coming from the gathered data is the third main capabilities that we see as a common requirement patterns across different industry, telco, manufacturing, retail, healthcare, fintech. What does it mean leveraging or harnessing AI/ML on Openshift and mainly with this kind of edge deployment? If you look at the challenges that must be managed usually by the different key personas involved in AI/ML application creation deployment, the development of the machine learning model and the deployment of that machine learning model as an app in production are probably the steps that requires more attention in terms of IT management, in terms of how I want to consistently develop and deploy that application, that model in production, whatever kind of, we can say, kind of cluster, Openshift cluster we want to run on. So starting from the data center to the edge, and we want to do it in faster, and we want to do it in a consistent way. Red Hat is investing more and more in order to enable AI/ML or in order to have implementation of AI/ML workflow in the edge deployment we just mentioned before. That means that we want to provide with our stack capabilities that allows to support all the AI/ML workflow, usually starting from setting the goal in order to decide the key metrics I want to measure the success of my model with throughout the machine learning implementation and deployment into production. The first question could be why containers and Kubernetes for AI/ML? I would say because first of all, portability. So if we speak about edge computing, I want to be able to freely move the workloads, intelligent workloads throughout and develop throughout all the different kind of clusters I do have in a consistently way without reinventing the wheel if I have to deploy that machine learning model in a standard data center or into the small cluster into the edge. And one second point I would like to underline is I would like to provide a way to provision fast an AI/ML environment. So if I do have data engineer, data science that just want a Jupyter notebook environment in less than 30 minutes, yes, I want to be able to provide it instead of every time deploy a new cluster or a new platform as a service, deploy some tools, recreating the wheel every time. And I want to do it in a repeatable way. So I want to be sure that I do have the same libraries, the same frameworks for different kind of use cases. So the second question will be, why Red Hat? Because I would like to say, not only because we are very well known for our Kubernetes release Openshift, but because we already know how to do CI/CD deployments and in a consistent way with the traditional application. And we are going to provide that capabilities also for intelligent application based on AI, ML frameworks. And because we were able to establish a strategic partnership with key players in the ML market, like NVIDIA, for example, in order to use and effective GPUs. If we just look now at the machine learning lifecycle, the usual one, in more technical details, and we can see that usually it goes from identify the metrics, codify the problem I want to solve, and identify the metrics I want to use to measure the success of my model. Then we move to the data collection and cleaning, and in order to implement my feature engineering. So I want to know which are the kind of data that I want to use to train my model. Then obviously I want to train my model, tuning it, and then deploy in production, and have the way to measure the success of that model, or how that model is going through the time. And if we think about how it works with the usual application, so starting from feature request, for example, then develop, test, and production is not that different. So probably the main difference is the semantic of the single step, but that from workflow point of view is not the difference. That means that the reason why Openshift is able to provide to the data engineering phase, data science, and app development, the same kind of experience. And from not only from developer point of view and ops point of view, the platform is always the same, and it's consistent in all these different use cases. How we are going to do it? How we're going to provide this capability? Thanks to Open Data Hub. Open Data Hub is a reference architecture, is more than a product, is just a frameworks, and that is able to provide the different layers needed in a typical AI/ML application development phase. So tools like the TensorFlow, languages like Python, could be Spark, and Jupyter notebooks in order to have data scientists, data scientists experiments on the data, machine learning data services, or like SQL or NoSQL as well, and then a common hybrid cloud platform managed by Openshift, leveraging compute acceleration like GPU, and that is true throughout the different kind of deployment, from physical to the edge. So any workload, anywhere. This is a picture of Open Data Hub. It's an open source community project that by which Openshift can automate the deployment of open source tooling. These are just some of the frameworks and tools provided by Open Data Hub on Openshift. Just to mention some that are probably the best one for the ones that want to develop an intelligent application. So Apache Spark, I know doesn't need to be present. Argo CD to implement the GitOps workflow for AI/ML application. Grafana Prometheus in order to implement and visualize the metrics I want to use to measure the success my model, and Jupyter notebook in order to provide a multi-user experience on Openshift. These are some of the also some of the community we are working with. We already mentioned NVIDIA, so you can leverage NVIDIA CPU GPU optimized thanks to Openshift. And some key workflows or some key use cases you are able to manage thanks to OpenData, the framework OpenData Hub. It is the data acquisition and preparation. Provide the Jupyter Notebook as a services. So whenever there is a need for a specific new project, so instead of recreate everything from scratch, you just provide Jupyter Notebook as a services. Machine learning model and serving and inferences. So you can provide a model as a service. And then, as we mentioned a lot of time in this during this presentation, managing the continuous CI/CD development of machine learning model in production. Just to show them in more detail, there's the data acquisition part of preparation, leveraging, for example, tools like Apache Kafka, called in Red Hat MQ streams, and feed my AI/ML platform. Jupyter Notebook as a service, so you can just provide a, let's say, multi-tenant environment for Jupyter. So with one platform, manage a different data science team. And what is created on Jupyter can be then deployed as a service using frames like Flask or Seldom, or you can just provide an image, CI container that could be deployment, definitely on Openshift, or if you don't have enough resources on Openshift, on a small environment, having just RHEL with a light footprint. Before going to the demo, where we see just a very simple workflow, AI/ML workflow, these are some of the strategic partnership we do have in the AI/ML ecosystem, just to show that we are going serious in this domain. So, and we are in the typical open source way. We understand that you can't do it everything alone, and we like to involve in this kind of community project and other partners, other key players. Let's now see briefly how we can leverage OpenData Hub on Openshift, just having a very easy way to deploy what is built inside a Jupyter notebook and having it provided as a service. And the final model, we train it inside the Jupyter notebook.
I love live demos.
Thanks, Natale. Please don't interrupt me, please. So as you can see, OpenData Hub, like everything now, like third-party software, or also Red Hat software running on Openshift is deployed as an operator. Obviously, for the sake of simplicity, the operator was already deployed in his small OpenShift cluster. You can see part of the components comprised in the OpenData Hub framework, and you can see here that the instance is already up and running. One of the things that we want to do, just provide, as we mentioned, we have, let's say, a data scientist team that asked for a new Jupyter environment. We want to provide it as soon as we can. So we have already here what we mentioned before. You can see the routes. So that means the service we expose through OpenShift is the Jupyter services with a specific rule. Here we are. We start our Jupyter environment. we have the opportunity to start from the cited notebook image. We will use this one because it comprises and includes all the frameworks and libraries needed for the kind of use case we are going to implement. You can have a t-shirt sites deployment based on obviously the kind of resources you can use. You can specify starting GitHub repository, what we are going to do, where everything is already built and implemented. In case, as is not the case, you have access, so you need access to Ceph storage. You can specify because everything is, or you want to provide any kind of different storage, you can just provide the key to access, and if needed by the notebook, you can provide the environment variable. Here you can see the servers is starting up, and everything is available from the data for the data scientist team. Let's start from the feature engineering part. Also, what we are going to do, the first notebook, so we will show a feature engineering technique. So the goal is to turn text documents into vector. We want to be, the model we are going to train will be used to see if there is spam documents in a text. We want to be able to split spam document from legitimate text, and we want to be able to do it in an effective way. The way we will start, we will do feature engineering is using a very simple technique. So the text frequency inverse text frequency. So we want to be able to understand if there is a separation. So we will take the training data. We want to see if there is a separation between the legitimate documents and the spam one. So let's run it. The notebook. We are going to use scikit-learn framework. We loaded we created the pipeline where to which we will apply our TF-IDF transformer, and that is the plot that show us that there is more or less a clear separation between legitimate spam words that you can see in the bottom and the legitimate words that you can see in the upper part of the diagram. So as soon as we are able to identify the data we want to use to train the model, we are going to do it. So let's load the Jupyter notebook where we have our training phase. We are just going to use a very simple model. So logistic regression, we take a text and we tag the text as a spam or as a legitimate. Let's run it. And also in this case, we are going to use a very simple library coming from Scikit. And in order to see if the trained model is more or less effective or not, we are going to plot a confusion matrix. In a confusion matrix, we have the opportunity to say how many times we identify legitimate words as legitimate is this box, or spam words as a spam, that's this one. In the other diagonal, you can see actually when you identify spam words as a legitimate, so when the model fails, let's say, or legitimate words as a spam. And it looks like, looking at the numbers, the model is obviously working pretty well. Also, if we look at the raw numbers, raw count, we can see, yes, probably this model can be a good candidate to be deployed in production. Now the real challenge is how I'm sure to have what the data scientists have identified as a good model consistently way deployed into production. That's where, again, Open Data Hub comes to help, because we can build a workflow pipeline, a deployment pipeline, where we will start from the 2 notebook that we already deployed and created, and starting from this one, what we will have will be just an HTTP mod services that we can use just to provide the model as a services. So let's start building this. I already built the workflow, and we already have deployed the model as a services, and we are going to see, first of all, how we are going to call it in a Jupyter notebook, and using now a different text coming from Pride and Prejudice. And so there are part of the Pride and Prejudice text, and part of that is spam. And one of the biggest thing of this, the part where we are going to predict which are the legitimate part of the text, which are the spam. The biggest part of the sorry, I clicked on this one. That's the part. So that's part where we are going to use the services and the model provided as services. So let's run it.
Sorry, guys. I'm jumping in real quick. I know you don't like to be interrupted, like you just said.
No worry.
But can you wrap it up in 1-2 minutes max?
Yeah, and just to say that we are able to provide also out-of-the-box metrics that you can see here. That matrix shows us, in this case, how many times we do prediction on spam legitimate, how is going along the time, the model. And if you see something like this shift, that means a long time, probably we are going to predict more legitimate words than before. That means probably there is something in this model that should be corrected to some extent. But anyway, this is something that we can provide to the data scientists to say, well, probably this is something that doesn't work. Please, can you take a look at it? Everything, just to close, standard CI/CD to deploy a different kind of application, probably usually one runs on Openshift, from development, from the data scientist to production, from the data center to the edge, consistent way. That's it. And thank you, obviously.
All right. Thank you very much. Like I said, you're probably used to, like with the other speakers, that you're at OpenSlava and then applause and people go crazy. But here in digital, they said it. But I'm excited. I'm excited. And I'm not going to do questions because the next speaker is already ready. But
okay.
People can reach out to you. Probably already
yeah, please.
Know you for a long time. So Natale Vinto and Fabio Di Vita, reach out to them if you have questions. I see the clapping hands coming in. I don't know if you're on the Hop-In platform. Thank you so much for doing this, guys. Glad to see you again.
And see to you soon next year in Bratislava.
Let's hope it's physical again. Let's hope. So thank you, guys. Thank you very much.